Hello and welcome again to another Trino meetup. It is that time of the month again where we talk about all things Trino community, and find out from our users all the benefits that they are reaping from using Trino. Today I'm joined by Michael Cecino from Visible Systems, and believe me, it is going to be very interesting when I tell you, when you find out more from what he's up to. Hi, Michael. Thanks for joining us.
Hi, Manfred. Glad to be here.
Yeah, it's excellent. So let's jump right into our chat. Before we let Michael take over, let's do a few housekeeping items, which leads us to first talk about our topic of the day is constructing an intelligent data trellis from your data mesh. We're going to have to unpack this a bit, but before we do that, a few community updates. I'll talk a bit about Starburst and Trino as part of our Trino community outreach and work here. And then we'll let Michael tell us all about the data trellis and the data mesh. I might end up even talking about a little bit of data mesh to bring some context before in our introduction. As you know, this is a Trino meetup, so this is all for the community, by the community. If you're interested to join us, a lot of interaction happens every day with thousands of users. I think we're like over 7,000 by now already, definitely over 6,000 users on our Trino Slack community. Brian Olsen and myself monthly host the Trino community broadcast, which in fact is going to happen tomorrow. So make sure you put that on the calendar. We'll be talking about the different packages that Trino ships in. So the RPM, the tarball, and the container, and how to use them and what the pros and cons are of them. And then today we have a Trino virtual meetup, the Trino Americas. There's also some in EMEA in the APAC region. In general, obviously, Trino is an open source project, so reach out to us on trino.io/development. You can find out more information, including the link to the GitHub repository and other things. And you can also help us with documentation or blogs, or even just writing on your own blog and telling others about Trino. Another very important thing that's coming up for us is we will be celebrating May, Cinco de Mayo. No, we're going to be celebrating Cinco de Trino with Commander Banban, the team from Starburst, and a whole bunch of other people out of the Trino community, various Lakehouse users, client tools, and so on. There'll be lots of fresh content, updates from the Trino community, exciting developments, Project Tardigrade upgrade, and the features for badge support going live, and many other things. It's a free event, so please register at the URL on here, or just look for Cinco de Trino on the Starburst website. It's not far away and should be super exciting. I'm sure Michael is going to be there as well, and chime in the conversation there, I hope.
Looking forward to it, Manfred.
Yeah, should be interesting. I'm helping plan a bit of the content, and I'm very curious on some of the things that are happening. So I'm looking forward. So you should be too. Also, the Trino forum, as you know, beyond helping on the Slack community, the documentation, our conversations we have on GitHub, pull requests, and contributions, the Trino forum provides a great space for providing curated information, question and answer format, all indexed and available in their searches. So chime in at trinoforum.org for that. It's also linked on our website. And if you're joining us today and you do not wear one of those cool T-shirts that Michael also wears today, you can get one too. Just follow the link here, starburst.io, info America's virtual Trino meetup T-shirt for me. And you can get a Commander Banban T-shirt as well, with love from Starburst. Our fearless leader, the Commander Banban, will of course also join us in Cinco de Trino again, maybe even with some music, we'll say. And by the way, we had Commander Banban play some music last time, so it should be fun. As usual, with this meetup that we're doing today, this is running on StreamYard, and we are streaming live to YouTube, so you can ask questions right there, or also on the Slack channels or Twitter, TrinoDB. We'll try to find out any questions are being asked, so that we can talk to Michael afterwards and see what comes up. I'll be also hanging out and potentially even interrupt him if the questions are in the context. Now, before we jump to Michael and him explaining to us about data trellis and data mesh and other things and how he uses that to elevate the business context and create that sort of information and insight with the actual data, let's talk about a little bit about Trino and Starburst first. As you know, or maybe not, Trino was founded quite a while ago. It's 2012, originally under the name Presto, but now all under the name Trino with Commander Banban. And the founders of that project, Martin, Dane, David, Eric, and others, all of those top contributors are now with Starburst and driving the innovation forward very strongly. Trino has seen lots of growth over the last couple of years and is a very, very powerful community and tool integrated by all sorts of users across the industries. So what is Trino? Trino is a high-performance, massively parallel SQL query engine. What does that mean? It means that you can connect any kind of data source, such as object storage systems that are powered by Hive or others, or where the files are in S3, but also relational databases, Elasticsearch, and other systems that don't even support SQL. And all of those systems can be connected and then queried from a Trino cluster. Massively parallel because there's many servers in a Trino cluster that all talk to the storage. So they can create the results of those queries much faster than a single server could do. And it scales to massively large data sources of many petabytes and very high concurrency of users. It's an open source project with contributors from all across the ecosystems. And if you want to see who's helping us, you can see from the Git commit history or even just from the user testimonials on the Trino website. There's lots of well-known names there that work with us on a pretty regular basis. Trino separates the storage of your database system from the capacity need for processing that data, which means if nobody at night, for example, needs to run any queries, those can be shut down and you can run those queries only and run that infrastructure only when necessary. That infrastructure can be really pretty much anywhere. We'll talk about that also tomorrow in our Trino community broadcast, where you learn that all you need is really Linux, and it doesn't matter if it's a bare metal server, a virtual machine, or a container deployment. On cloud, in premises, Trino works everywhere. Now, Starburst is sort of the company around Trino. As I mentioned, all the founders of the Trino project and many other top contributors and people active in the community are with Starburst. And we provide two products, Starburst Enterprise and Starburst Galaxy. Starburst Enterprise basically offers enterprise features, more performance, security, support from our experts, and other aspects for your own deployment where you manage it yourself. Starburst Galaxy, on the other hand, is sort of a hands-off software as a service application where you don't have to worry about all the details of running the infrastructure. We take care of that for you. And that is a very useful model for anyone that can't have the resources to, have a dedicated team of data analysts and platform administrators, data engineers that know all about the data sources. And you'll see later on from Michael how beneficial that is for him, for example, as a Starburst Galaxy user. He doesn't have to worry about running all the infrastructure. Starburst is now has 150 or more customers. We are over 350 people by now. We've raised a couple of $1 million, a couple of hundred, in fact. So we're doing quite well, and we're growing like crazy. And we're always looking forward to bringing even more benefits for our Trino users in the community. How this works in an overall system, you can envisage this here. As I mentioned, there's all these different data storages, such as Google Cloud Objects, Delta Lake, MinIO, Object Ceph, relational databases, NoSQL stores, and then also systems like Kafka in a typical publish-subscribe models of streams and so on. All of these systems can be queried. You can add additional security with our built-in access control or with Apache Ranger on top of that, so that your enterprise usage is secure and users can only see the data they should be seeing and not any other data. And those users can be data analysts, data scientists. They can use tools like Looker, Tableau, ThoughtSpot, and others. And those can also then create dashboards that can be visible by high-up managers to really understand the data, drive the business, and make things successful for you. And the cool thing about this is, because the analysis of the data is so much faster, you can understand your data much better and therefore gain much better insights. That also leads us to our presentation with Michael. And I will stop and share my screen and switch over to Michael's screen, because he will talk to us about constructing intelligent data trellis from our data mesh. Welcome again, Michael. Thank you for hanging out with me and teaching us about your efforts with Starburst Galaxy and all the cool analysis and insights you're gaining.
Oh, you're welcome, Manfred. And thank you for the introduction. And yeah, if anyone should happen to post a question, please just stop me. I'd be more than happy to respond during the presentation. As you can see, Visible Systems is located in Boston, and we are, in fact, a neighbor to Starburst. We met about 4 years ago. We were sharing the same cooperative office space. So it was nice to get involved with your initiative, Manfred, way back when you first started.
Yeah, you've seen us grow a lot, right?
Yes, I certainly have. And we, in fact, had started with Starburst Enterprise and then moved over to Galaxy probably about a year ago.
Mm-hmm.
So, so we can appreciate the functionality in both of those products. And Galaxy certainly is a welcome addition.
Yeah, that's cool.
So let's talk about this so-called data trellis. And before I do, I just want to talk a little bit about a story. And the story is that there was a small grocery store with half a dozen locations, and they decided to run a sales campaign for each location with some variation in the campaigns. And after a few months, they noticed that the sales were kind of flat in all but one location. And they thought that maybe it was this particular campaign that was unique to that location. So they figured, well, you know what, let's replicate that campaign in the other locations. So they did. After a while, there was still no change. And what they found out later on was that there was a for sale sign on paper towels that happened to fall in the window and turned upside down, if you will, but still visible to the customers coming into the store. And that was what caused that particular store to increase their sales of the paper towels. So, you know, to look at a quote by Mark Twain, what gets us into trouble is not what we don't know. It's what we know for sure that just ain't so. So the reasoning behind it all is, hopefully, through Trino, we're able to see the data that we normally would not see. And we're able to know what is true that, in fact, is true. And that's where I want to kick off this particular presentation. Peter Drucker put it another way. He said, strategy is a commodity, but execution is an art. And we did some surveys and studies ourselves, and we found out that somewhere between 50 and 90% of the strategies devised out there underperform. Over 60% said that it's because of their inability to track progress due to the lack of insight into the strategy execution. They point that out as one of the biggest obstacles in performance of their strategy.
That reminds me a bit about the saying where people are saying ideas are cheap, right? Like the hard part is making it happen, right?
Absolutely. So Visible's mission statement is to enable the enterprise to drive strategy to execution. We do that through something called composable business models and in combination with discovery of purposeful data. So we close that gap between strategy planning and execution. Well, what does all this have to do with a so-called data trellis? Well, first of all, let's define what a data trellis is. And in doing so, I simply looked up the word trellis. And in the definition of trellis, I pull out a couple of key words: architectural structure, open framework, interwoven or intersecting pieces of the wood, bamboo, or metal that the trellis is normally constructed from. And it's made to support something that's climbing plant, for example. So you can picture this trellis. I have a photo of a picture there, an image. You can picture the trellis as something that kind of bridges a gap between what? Between the data mesh and the overall objective of why there is a data mesh. So in our case, for our mission, it closes the gap between the strategy planning and its execution by instantly mapping the conceptual representation to the physical world. It also is important to continue to promote self-service so that the non-technical users, customers, can seamlessly work across the value streams and digital assets and work packages. So that in and out of the data mesh, they can climb up and down the data trellis. Henceforth, it enables teams to collaborate that way. And finally, it follows the FAIR guiding principles. And I'm not sure if many of you have heard of what FAIR guiding principles are, but if FAIR, findability, accessibility, interoperability, and reuse of digital assets, all designed to promote reuse of data, increasing the volume, complexity, and velocity of data. And you can, for those of you who have an understanding of Trino, you can see how Trino really is the backbone of this. It's the backbone of the mesh and the trellis, for that matter.
But you are adding the framework, so to speak, to hold that trellis up and elevate the underlying data and the mesh to the higher business value. And I think that's
absolutely, that's a very good
cool
way to put it, Manfred. Yes. So where is potentially, how do we look at where we start? And we start really on the top of the trellis. What does it look like on the top of the data trellis? Well, at that juncture, we have the ability to define what our business is. We have the ability to develop the rules about the business. And in doing so, we define things like schemas and procedures. And with those business definitions, we're able to better align the needs of the organization with the data that we depend upon. So using an advanced design layer architecture, we're able to create with one or more models focus on the business requirements, and those models then can be linked further along down the trellis as we get from a design layer to an actual implementation layer. And that's where we see the data resident in the data mesh. So we're linking from our top level business requirement, if you will, all the way down into the data itself in the data mesh. And that's the whole idea of the trellis. While we're doing that, we're democratizing data. We're storing the models in a central repository. We're providing a simple way for people to get to those models, review them, and so that requires something of a open central repository. That way there, everyone is able to share the metadata. And that's certainly important because the metadata is the foundation of what we're trying to utilize. And if we can do this properly, what are we getting in return? We're getting insight. We're actually getting insight into our business. We're deriving those insights from the data mesh. The only way we can do that, however, is to prepare and couch the information that the data mesh needs from us in order to give us back and return back to us what we're looking for and making better decisions ultimately. So let's take another look at this in these areas a little bit more closely. And this is more of an overview for us. Visible Systems has something that we've implemented in our architecture called planning statements. And what these planning statements are, you'll be looking at them in more detail in a few minutes. But what they are is a means of defining the business, maybe defining the strategy. Strategies, by the way, can be defined at any level. You don't have to think of a strategy as something very complex, like the whole business taking over, acquiring another business. Yes, that certainly is a strategy. But strategies also are found at another micro level. For example, it could be an operational strategy. It could be something very specific to a product feature strategy. So I want you to understand strategy in the sense that it's not totally holistic all the time. With the planning statement, we can define these strategies and link them to the goals and objectives of what the strategy intends to accomplish. And from that, we also can link into these so-called knowledge models. These are the conceptual models of the data, of the processes, of the use cases upon which the strategy depends. When we have the knowledge models in place, we climb down the trellis and we map all of what I just mentioned to the physical world. And the physical world is where the data resides. Real-time data, near real-time data. That data is important. And it's important that we map to it properly, because if we don't, we can't get the actionable insights back to make those important decisions in time. Trino plays a critical role in that. It's the engine, the processor that takes what we're mapping and returns the results back to us. And that's why Trino is really so important in this architecture.
And in your system, you're kind of figuring out what the measurable entities are, what the criteria are, and then with Trino, you are figuring out how to access that data, essentially. Does that make sense?
Yes. And we have, and I'm glad you mentioned that, Manfred. At the very top level in the planning statements, we have KPIs, key performance indicators, and those also get translated down so we can get the data back and measure our performance against the key performance indicators.
I imagine that must be pretty complicated sometimes to figure out how do you measure things and like find the right thing to measure, right? Like you don't lead down the wrong track, so to speak, and measure the wrong thing. gets you the wrong insights then.
No, you're right. But the nice part about it is this is an iterative process.
Okay,
So
very cool.
yeah, you're continuously checking as you're going along, and you can adjust as you go along.
Awesome.
Now here's a little more detail on each of these areas. So I did mention a little bit about the planning statements. You know, they help us develop a comprehensive strategy, addresses goals and objectives, is accompanied by KPIs. Strategy could be clinical, customer related, market related, product related, or operational. One could very well apply a SWOT analysis, Porter's 5 competitive forces or Devonte's 7 S's, to better define their strategy. And that's all incorporated. And in a matter of fact, one could define a strategy for specifically SWOT analysis and climb down the trellis into the data mesh, mapping to the correct data, and returning the data that would indicate would indicate the SWOT analysis, and therefore whether or not this is a valid strategy. Likewise with the Porter's 5 competitive forces. Knowledge models, again, we're linking all the models to the planning statements. That's a key point because we need that continuity. We need to translate from a planning statement down into the different models, the knowledge models. What are they? Well, I picked 4 or 5 of them here. So, and some of you may already be familiar with these particular models. There's the use case diagrams. That's governed by the UML 2.x standard from OMG. Some of you may be familiar with that. Essentially, it's just to understand how the users will interact with our strategy. There's the business process model that conceptualizes and aligns a process to a strategy. There's a sequence diagram. It represents sequence of actions and system interactions. There's the all-important data model. It helps us visualize the data and the relationships that are needed to support the strategy. And then there's a virtual view, which is a custom specific perspective of the data for a specific purpose. And the views are automatically generated by our platform, by the way. It collects all of the data from the above models and generates the view automatically. Then there is some mapping. The mapping is taking the metaverse of knowledge, which is all the metadata, and mapping it to the physical world. Now, in the demo that I will show you, I'm going to show you 2 demos, one of which shows you right up front how AI and ML mapping can be applied. The other is just a straightforward mapping scenario. The AI ML mapping algorithms, or the way in which to do that, is something that we're still looking at. As a matter of fact, it was developed in cooperation with a capstone project by 4 students at Northeastern University. But you'll see that in more detail later on. Finally, is the massive parallel processor Trino. Why Trino? Superior performance for real-time analysis, which may be important across different strategies that you're using. You can scale the computing and storage independently. That helps tremendously in separating what you're storing from what you're computing. It dynamically scales the computing cluster automatically, as is the case with Galaxy. So we're hands off. Galaxy can automatically take care of any scaling that needs to be done. And finally, it aggregates data across disparate and distributed data sources. Very important when you're dealing with business strategy. Why? Because that data is so diverse. You don't want a strategy for which you can't essentially prove. You want a strategy that can actually bring data in from many sources so that you can prove your strategy out and you can see how it's executing. So let's take a quick look at what these planning statements are. This is just a 3-minute video, I believe. They'll walk us through just the basics of a planning statement. I have a little image here that you'll see in the video. The reason why I have the image here is because I want you to understand that these planning statements are by nature hierarchical. So there's a dependency and a relationship in between and across planning statements. So let's take a look at the video now and see how that plays out. Let's now take a look at an example of planning statements. Here we have a set of planning statements that are designed to address a mission of market analysis. Notice that we also have, following that mission, we have a goal, objective, a strategy, and an insight. If we look at the goal and just click on it here, you'll see a definition of what, or a detailed description of what the goal is, referring to it as consumer analysis. Notice also that this goal is actually linked to a couple of functions called market analysis and consumer analysis. These functions are defined elsewhere in the repository. The most important point is that the goal is linked to these particular functions. And you'll see that if we click on, for example, strategy, the same comes up with this detailed description of the strategy. In this case, we want to align the product promotions to consumer behavior. And that particular strategy also may be linked to different objects. Most importantly is the insight. The insight is the data that we get from our self-service data discovery that informs the strategy. We click on the insight, it's to identify which promotions are the most effective. You'll see a detailed description of the type of query that will run to get that data. And also you'll see a link to the entity that's involved in giving us that information. In this case, it's linked to something called promotions. Now, if we exit out of that, there's one other point that I'd like to show you, and that is that these particular planning statements can be defined and set up by you ahead of time when you first create your project. And you can do so by clicking on planning statement types. So each planning statement has a type that you can assign to it. And it also has the ability to take that type and define it as a composite type, which means then that it can be linked to any particular object in your project, and to define the cardinality of that linkage, meaning that it can be linked to only one and one only object, or it can be linked to many objects. In this case, we have a business rule that has a cardinality of many to many, meaning that there are many business rules that can actually be linked to many other objects in your project. Okay, so on the next visual here, I'm pointing out to you the fact that based on the linkages between the planning statement and the data model, you can then simply by using a graphical query builder, you can then show which tables you want to join together in generating an insight. And here I point you out to the fact that this particular insight is already it will be generated, and it's generated in the syntax of whatever you're mapping your model, whatever physical store, data store you're mapping your model to. And in addition to that, you can view, visually speaking, the actual model or the entity relationship diagram that is behind the generation of the SQL that actually get run.
So where is all that metadata coming from, Michael?
So the metadata is coming from the models that you created, service customers, addresses, and suppliers. Now, these models, you can create them offhand, if you will, or you could actually create these models by reverse engineering the metadata from whatever data stores you feel you want to eventually query. So there's two ways of doing it. So it's either, again, you create the new model, or you can create a model from existing data.
So if some application developer worked already with a business analyst to figure out the sort of model, you can basically reuse that.
That is correct. And when you're creating a model from a strategy statement, you will key in on the description of the strategy in terms of what are the nouns that the strategy that's used in the strategy statement. Those nouns typically will give you an indication of what data you're going to need to support that strategy.
That's cool.
Now, we have a human trafficking use case that we're going to look at. And in this case, what I want to describe to you is the fact that we're moving from a knowledge source, and that knowledge source typically is what? It's embedded in clinicians themselves, clinical guidelines, okay? But we're basically garnishing that knowledge and representing it in the models. That's the information that we're moving along here, on the top of the template. We're mapping that to the actual data. And what's important here is that the feedback that we're getting is considered knowledge as well. And that's the kind of feedback that we need to do the proper analytics on the data. So, again, this is a kind of a horizontal plane of moving from knowledge to information to data back to information and knowledge. The trellis is a vertical plane. So let's just keep that in mind, because this next video that I'm about to show you is a video that I believe it's about 7 minutes long. And this is the one that was done by the students at Northeastern University. And what they're doing here is they're showing you a framework for how to apply artificial intelligence, machine learning, to the task of, well, what is a good fit? What model is a good fit for us to better do the mapping between the conceptual and the physical real world? And how do we actually do that in a way that we can kind of track what we're doing? Meaning, what's the governance behind the model itself? So we'll take a look at that now.
The governance documentation outline enterprise level of governance policy and strategies. For example, the enterprise architecture and the strategies indicate the key components contributing to govern and support the AI operation, which my teammates had elaborated the detail earlier. One big benefit of making the EA framework visible to the employee is that it gives the employees the visibility to the overall enterprise architecture. When there is a business change, requests can be submitted to EA Architect to review and re-engineer the enterprise architecture. The last part of our demo is a business use case demo. We will be using the human trafficking dataset to simulate how the team handled machine learning project using DataViz. Here's the business context for this demo. A global NGO is performing data research work on global human traffic problems, aimed to provide data learning to local authorities to implement strategies for preventing the human traffic and the rescue victims. When we receive this request, the project manager, Joy, would submit a new project request via DataViz for approval, like this. Fill in project detail information and click Submit Request. Once the project is approved, all project team members are on board and granted access to this project during project kickoff. Next, I will demo how Matt, the data scientist, uses DataViz to support this project. The first step is to obtain the data required for the project. A task card was created and assigned to Emily. Once the dataset is ready for use, the next step is data cleaning. Data cleaning takes most effort in the early phase of the project to ensure the project's success. Emily noticed the dataset was open source, so she needed to carefully evaluate the data quality. Alan, as project sponsor, then reviewed the evaluation report, approved to proceed. Once the clean dataset was ready, Matt created a new task to perform EDA on Databricks. And the EDA dashboard can be created on platform, including both DataViz and Analysis. From the dashboard, we can gain some insights, such as female victims are 72.8% of data population. In the past 15 years, between 2010 to 2012, the number of adult female victims dropped while the adult male victims increased. However, the majority of the victims are still adult females. When the analysis report was ready, Matt communicated with project sponsor Alan and requested a meeting review. Alan provided his input into EDA. After Alan signed off the EDA phase, Matt continued to explore, experiment, and compare a few models, and then make a recommendation based on model performance. For example, initially, Matt had tried a linear model and found no linear relationships. Then random forest was applied and generated a feature importance map. Matt had also tried a neural network, but it ditched the neural network model due to poor performance. Matt scheduled a meeting with the team and the sponsor to go through the finding after sharing the model dashboard, and eventually choose random forest as the final model into the model tuning phase. During model experiment, Matt uses Databricks MLflow to check the experiments. The tracking record can be downloaded and uploaded to the DataViz project. The benefits of doing MLflow is that it enables other data scientists to use the experimental record to understand what has been performed. The team realized that although random forest was effective in identifying feature importance, such as gender and age group, its accuracy was still far away from satisfaction after a heavy tuning process. So the team determined that the model was not ready for deployment, and the project required either more data variables or trying out more models. Therefore, the team needs to reiterate the last few steps to get a more optimal model. This is how Matt, as a data scientist, interacts with the database system. That, ladies and gentlemen, was what we wanted to share with you today. Thank you all, and we are ready to answer any questions.
So I want the audience to understand that, in fact, there is a place for machine learning and AI in basically constructing the trellis and making sure that the data coming from the data mesh is in fact mapping correctly, both up and down the trellis. And the idea that the students, by the way, were under a capstone project sponsored by Visible Systems, and they made tremendous progress in understanding which machine learning models would be the most appropriate. And as it turned out, MLflow was one of the ones that they selected and will continue working on. So that's a work in progress that we haven't yet implemented into our platform, but it's something I want to share with you on this particular presentation. So now we're going to look a little more closely at how we're aligning the overall objectives and goals of human trafficking and detecting human trafficking with a strategy. So when we view overall, we're trying to assess the societal and economic impact of human trafficking, and it's all brought up within the context of raising awareness about human trafficking. The objective is to organize the medical community to provide a safety net for the survivors. The goal is to cut human trafficking emergencies by 30% in 3 years. So, by the way, goals are more definitive. Objectives are typically a little more higher level than what your goal statement is at. So you want your goal to be somewhat quantified, if you will, and your objective will be more qualified. Now, the strategy to meet the goals and objectives would be to correlate global trafficking data with emergency room encounters. That way there we can determine the demographics, labor category, and country of origin. We also want to look at the execution. So the idea is that we're trying to identify a high concentration of trafficking across countries while we assess the mitigation patterns relative to countries, regions of origin, and destinations, as well as industry. You might recall in the previous video that although the number of female victims is high, that the number of male victims was increasing. And the reason for that is because during a period of time, there was a shift of bringing male victims of human trafficking into the United States for the purposes of labor. And there was a demand for labor, and that was an uptick that we saw in the number of male victims of human trafficking. So the question is, how do we know if our strategy is working? And if it isn't, how do we adjust our strategy? Well, if we're dealing with global data, we're dealing with data sources that are coming, to us from different countries. So one key is going to be to double check the source of the data. Understand is it credible? And here is the opportunity to apply machine learning and artificial intelligence. That will help us determine the accuracy, credibility of the data. Also, is there a data lineage that can be proven? In other words, can we link this data all the way to the original source? If we can't, then there's a question of credibility of the data. If we can, certainly that makes the data source that much more credible. Okay, let's take a look at the execution. What's the context in which we're operating in? It's to correlate patients taking a survey, the Greenbaum survey, to where there is a high concentration of examinations in the same anatomical location. So in other words, we're seeing that someone that has over a population is a high concentration of an injury in a particular body part. Could be the back of the head or it could be a bruise. If that's the case, then are these particular patients also submitting to the Greenbaum survey? For those of you who don't know, the Greenbaum survey is a survey given to potential victims of human trafficking. Henceforth, the questions that are asked are germane to that particular type of patient. Now, the strategic issue is to incorporate human trafficking screening at points during the patient registration process. If in fact we find that this particular injury is local to a particular part of the body, then immediately, once that's detected, we can apply the Greenbaum survey. We can ask that those particular potential victims take the survey, and we can probably help them that much more quickly. So are our execution plans still valid? Well, in our data discovery, are there any insights that provide us with an opportunity to better service victims of human trafficking? Can we make improvements in the process itself? Can we identify where there is a potential for gaps in collecting the data during that process? That is to say, the process of when someone enters an emergency room or emergency department. Now, before I launch the third and final video, I want you to just let's step back and look at the trellis one more time. And let's take a look at the actors involved. Again, working top down, we're working from what we can do in visible systems in our platform by connecting strategy to goals, objectives, and KPIs, mapping the metadata models to the data sources, and getting those insights through our automatic generation of something called IntelliViews. Starburst Galaxy that we're using on our platform is the middle layer. It's the layer essentially that takes what we hand off as a model and essentially does the retrieval of the data in the data mesh. So it is a fully managed solution for us. It can scale at any point in time as needed. It makes the connection with, through Trino as the massive parallel processor SQL engine. It also allows us to federate the data from multiple data sources and aggregate the data across multiple data sources as well. That's handed off into the data mesh. The data mesh is where the ingestion occurs, access to the transformation utility of data collected from a variety of distributed data sources. Those data sources are both public data sets as well as online data sets. In the case of the human trafficking, the public data sets typically are the data is collected in different countries about migration of human trafficking. And the online sources, or the local data sets, if you will, typically are stored in an HL7 FHIR FIRE formatted resource, which is a standard for medical and healthcare information. One more point I want to make before we look at the last video, and that is the ability to reverse engineer. This is extremely important. Manfred actually brought this up earlier on. When Manfred asked the question, well, do I have to create data models from scratch, say, from the very beginning? The answer is not necessarily. Sometimes we will discover data that we will want to incorporate into a conceptual model. To address that, Visible System has the ability to reverse engineer discoverable data into conceptual models. So that way there, we're always working towards the so-called single source of truth. Even though we have distributed and disparate data sources, the idea of reverse engineering that into our overall model allows us to rethink. Rethink what? Rethink our strategy, possibly. Reconfigure our business models. That's why they're called composable business models. And that way there, we're having our strategy, our data models, which are taken into consideration the discoverable data when we reverse engineer it, and our business process models working in concert with one another. Henceforth, we're deriving business intelligence and analytics with more consistency and clarity, and henceforth gaining better insights from that. The use case to the right, it basically walks you through who is involved at what point of what I just described. So typically you'll see the enterprise architect and the business architect involved in defining the layout of the enterprise architecture. Typically you'll find data modelers and systems analysts developing those conceptual and logical models. And typically you'll find the business analysts working with the business intelligence leaders and defining some of the business processes. And finally, when everything gets mapped over to the platform and web portal, that's where all the self-service data discovery can happen by both business users, business managers, and non-technical users. Here's a view of the query, one view of what one query interface looks like. You'll see this next in our little demonstration. But as you can see, quickly, the insights are mapped automatically for you to choose from. You choose an insight, and you'll get the data returned by Trino to the interface, so that then you can do your further analysis on that data. So with that, let me begin. This is the last demo, and I believe this demo runs about 11 minutes. Now that you have modeled your strategy statements and your data and processes, with one click, you are able to publish your models to the portal site. Let's get started here and take a look at what the portal site does for us, in so much as connecting to Trino and the underlying physical data sources. So we'll proceed by logging in to the portal. And once we log into the portal, we will be presented with a list of projects that we have been working on. In this case, I will scroll down to the Human Trafficking Live Demo project. And just a quick note, I can archive any one of my projects, and I can share any one of my projects with anyone who happens to be on my project team. So we'll click into the Human Trafficking project and notice that there are 3 actions I can take. I can get insights into my project strategy. I can view and discuss the project strategy and the conceptual models. And I can run a data product from my project models. Let's take a look at the insights first. Immediately, I'm presented with the option of running a query or conducting a search. Had I not already connected my models to the underlying physical data, I would have had to do so by clicking on Connect. Here, I can map or remap my conceptual data to that of the physical data. So for example, if I click on details here, it will show me the mappings. It essentially gathered up a list of entities that are in my project. And if I click on any one of these entities that you see here, for example, encounter, you will see which physical database and where that database lives. And you'll see which entities and attributes, in fact, have been mapped to that particular database. And here you can see the fact that we are using Galaxy Starburst as our managed data service. So in this case, the patient registration is connected to the data entities that we modeled for the patient. And the beauty of this is that you can map any entity to pretty much any physical data source. It's because of the power of Trino that we're able to aggregate data across multiple data sources when we go ahead and conduct our search against that data. So let's go back to search. And once we do, and we click into the search box, we're presented with the elements of what it is that we like to search for the project. In this case, we had set up different views for that project, in addition to different planning statements, and finally, the data entities themselves. We can start a query on a planning statement level, or we can go ahead and query a data entity directly, or we can go ahead and get an insight on our data. We'll do that first. So what we want to do is get the data that correlates the rebound survey results to the encounter in an emergency department. Click on that, and in a couple of seconds, Trino goes out and gets the data, aggregates the data based on our query, and returns the results back to us. And here you can see those results. That there's been some notes and some evidence gathered during this emergency department visit. And we can see the list of patients who actually entered the emergency department and what the findings were of those patients. Now we can also go ahead and, if we want to zero in on one particular patient, we can do that. Immediately we get the results for Eileen Esposito. And Eileen Esposito is our example here, because she is the one who is in fact diagnosed as a victim of human trafficking. And what we notice in the data is we notice that the notes are similar. We notice that the injury is similar in so much as where it was found on the body site. And there's some other information, of course, that goes along with the encounter. Now, if we want to understand this information a little better, we have at any point in time the option of clicking into the model views. When we click into the model views, we're presented with the conceptual data. So for example, if we wanted to get a little better understanding of the query behind that insight that we just looked at, we can go up here and click into the insight folder and scroll down to that particular insight itself. Once we do, we're presented with the attributes that were involved in that particular query, and we are also presented with the SQL that was automatically generated for us that actually ran the query. We also can see different links that query was linked to. And here's a link, for example, to the planning statement itself. And you can also cross-reference from this particular planning statement to other objects in our project model through which we have a connection, or with which I should say we have a connection. So here's the encounter entity. Now, along with this, we can cross-reference to an actual workflow. Here is the workflow in the emergency department. And what we found in our query was that most of the injury was in the same area of the body. It was pretty much behind the head, and there were bruises also found on the body. Well, what we can do with that information is we can incorporate and improve our process to be a little more agile. What I mean by that is this. If you look at the current process here, you'll see that the green bomb survey isn't really an option until quite along in the emergency process. What we can do is put in a step in our business process notation here that if someone comes into the emergency room with bruises and an injury to the head, that we want to immediately conduct a green bomb survey, because it's more than likely than not that particular patient coming into the emergency room at that point in time is a victim of human trafficking. And that's the correlation that we found in our query results, I should say. So you can see how all of this just gels together for us, because we have the opportunity to connect our model or models, be it both data, process, and we connect those up to the planning statements, which is essentially our project strategy. And we saw what the project strategy is. We can look at that again. We want to go up here to our overview. You can see our planning statement hierarchy here, where we have the mission, the goal, the objectives, the strategy, and so on. And then connect everything down to the actual physical data so that we can pass that along to Trino. Trino will go out, aggregate the data, bring it back to us so that we can further analyze that data and get the kind of insight that we need. Finally, I'd like to just return back to our three options here. We saw the insights, we saw the model views, and now I'd just like to take a quick look at the data product. Now here in the data product, as you can see, we have the ability to go ahead and select any insight. So we'll select, for example, different insight here. And here's an insight that accesses the relative migration of where potential victims of human trafficking are migrating from. And in this case, you can see a description of the attributes that we will get back from the query. You see the actual SQL command that was automatically generated for us that will generate the view from which we'll get our data returned back from Trino. You'll see the actual physical database information of where the data reside. Again, Trino is able to aggregate this data across multiple data sources So here you can see those different data sources. We have a country sector, industries region, and industry sector, patient, and person. And then you get a quick glimpse of the data, somewhat data lineage. That is to say, the relationships across all the different entities and different views that comprise the data that were being returned by Trino. And finally, a preview of what that data looks like. So that ends my little demo here. Okay. Sorry, I think I cut off the very few seconds at the end. But I think you probably got a pretty good idea now, based on that particular demo, how everything plays in and plays together, if you will, in kind of constructing that data trellis from the data mesh. We do have a recommendation. We're able to get query details from how Trino ran. We're able to get the query details from Starburst Galaxy. But we're not able to actually include them in our data product. We would really love to do that. And I think the recommendation is to maybe look into an API that we can write to, so that we can get this information here that I'm displaying on this slide, and kind of figure out a way to incorporate that into the data product, the one that I was just showing in the demo. So Manfred, maybe that's something you can make note of and take up with the Trino team, or the Starburst team, if you will.
I know that there is some of those things that are exposed in a Trino web UI are behind a REST API already. And then also some other aspects, there is REST APIs and stuff coming for some of those aspects. So you might just have to chime in with more details that you're looking for.
I'll certainly do that, but that's good news, hearing that. Excellent. So with that, just a couple of concluding statements. And these statements are somewhat consistent with the data trellis. The idea is we want to join that well-prescribed data inside of an organization with discoverable data found outside of the organization. It's about conducting many searches that could be very different from one another. So what does it all give us? It gives us that built-in data integrity and consistency. We saw how to build that in at each level of the trellis. Allows us to fully integrate the business data. Somewhat, does eliminate some of the data wrangling and curation that needs to take place. We aggregate and join data across multiple data sources. Thank you, Trino, for that. And we hope that we can, in the very end, deliver what is a guided search experience, so that the users of this system can get to the right answer and get to it quickly. And that, again, is a benefit of our data trellis. So that's all I have. At this point, I will stop sharing.
Thank you, Michael. That was very interesting. It's good to see how there is, again, different usages for getting the understanding of what's the underlying data elevated to the higher business understanding. And also, it's cool how you basically have another product that Starburst Galaxy just ends up sort of the underlying engine that drives and makes it possible for you to create a product that is more catered, and you don't have to worry about those low-level details of getting the data.
Absolutely.
So question also, I saw that some of the data that you're querying is Hive, and then I saw MySQL also in some of them. Is that sort of like what you're mostly dealing with? Like when you're going sort of like on a fishing expedition of like finding all these external data sources, what are some of the data sources you find commonly?
Well, some of the most popular data sources are still SQL as a not only SQL data sources. Typically, MySQL, SQL Server. I think when you get into the more internal data sources, you find Oracle, obviously Microsoft. The external data sources, the public data sources, we did have to do a little wrangling with those. They came from a spreadsheet, actually. So we kind of wrangled the spreadsheet into a MySQL format. We would love to come across some use cases of data in Cassandra or MongoDB. So, the doc type of formatted databases. And we would love to see how we can aggregate data across those and include that data alongside of MySQL, for example.
Yeah, well, with Starburst Enterprise, you can definitely, in Trino, you can definitely connect to those kind of systems. And Starburst Galaxy is also on the horizon to do that. That's pretty cool.
Another point that I didn't make, I think, is the fact that when you looked at a business process, you saw the flow of different business activities through the process, but there are points where data actually gets created, and those are typically referred to as data objects or artifacts in your business process. Those equate to the data model. So there's a consistency between the data process, the business process, I should say, and the data model as well. And the link is actually the artifact or the data object.
Very cool.
Thank you.
Well, I don't see any more questions on our Slack channels and on the community out on YouTube and other places. So again, thank you very much for joining us, Michael. This was very interesting and enlightening. We will convey for the Trino community broadcast tomorrow, as I mentioned earlier. And we might see you in the audience for the Cinco de Trino event on the 5th of May. And for all of those that will miss those events, everything is also going to be available on YouTube as a recording. And so make sure you register so that you get notifications about those. And we will be back for another Trino meetup next month as well. So
thank you very much, Manfred.
Thank you, everyone, and I'll see you next time.